Fang just updated ALPHABOT 2, its newest general-purpose AI robot designed to set a higher bar in autonomous task execution. That's because, unlike its predecessors, ALPHABOT 2 employs its self-developed GO-VLA multimodal system to navigate and adapt to real-world complexity, handling everything from preparing food to doing factory work. But ALPHABOT 2's standout feature is its ability to learn and execute multiple tasks independently, adapting in real time to changes in its surroundings. In fact, where traditional vision-language-action-powered robots required users to carefully set up task objects within direct view, ALPHABOT 2 can scan its environment in 360 degrees, locate objects of interest, pick them up, and use them appropriately. Plus, ALPHABOT 2 can even respond to verbal commands as well as receive new commands to adapt its workflow in real time. But at the heart of its intelligence is its GO-VLA model, which serves as a comprehensive vision-language-action system to mark the robot's progress in 3 critical domains, operating seamlessly in open environments, evolving from single-arm to whole-body actions, and advancing from basic instructions to sophisticated planning and reasoning. Additionally, GO-VLA's structure is composed of a spatial interaction foundation, a slow-thinking module for reasoning and planning, and a fast response system for immediate adjustments. This fusion of multimodal input, combining voice, vision, and sensory status, enables the robot to break down tasks, interact naturally, and create coordinated movement and navigation strategies. And ALPHABOT 2's hardware is built to perform, with its lower body being able to adjust from 0 to about 7 feet 11 inches in order to reach high shelves or low cabinets. On top of this, its dexterous hands deliver precise force control for delicate operations, with the robot being able to interpret facial expressions and gestures too. As for the robot's body, it includes over 34 degrees of freedom, a 700mm arm reach, and a battery life surpassing 6 hours. And thanks to the robot's omni-body collaboration and complex long-horizon task execution, it's already clocking in and building cars in a factory in China, demonstrating its ability to turn off lights, pick up and sort materials, and much more. But robots are only as good as their hands, which is why Dexcel Robotics just unveiled its new Apex Hand, a groundbreaking dexterous design to transform how robots interact with everyday devices. Launched in September 2025 by a former key contributor to Tencent Robotics X, the company claims it's the first robot hand to be capable of operating a smartphone single-handedly, showcasing its potential for next-level applications. And when it comes to engineering, the Apex Hand balances multiple performance metrics. With 21 degrees of freedom, it replicates most human hand functions, achieving a full score on the Kapanji thumb opposition test for dexterity. Amazingly, each finger exerts approximately 24.5 newtons, or 2.5 kilograms of force, while the hand can lift up to 66 pounds vertically, making it suitable for both delicate and heavy tasks. But what's more is its response time, which rivals human reflexes, as well as a positioning accuracy of 0.1 millimeters or less. But robustness is an even more important design feature, with the hand maintaining stability under unexpected impacts. Plus, because the Apex Hand features self-developed flexible electronic skin, it offers sub-millisecond communication delays and a refresh rate exceeding 1000 Hz. And unlike traditional rubber-based skins that are prone to wear, this durable material provides high-fidelity tactile feedback for more nuanced interactions. In demonstrations, the hand can even navigate a smartphone, unlocking it, swiping through apps, and typing with fluid motions. It can also perform tasks like taking a pulse, requiring gentle pressure control, or manipulating small tools. This sets it apart from earlier models, which often struggled with consumer device interactions due to limited sensing or dexterity. And its potential applications extend far beyond gadgets. In manufacturing, it can assemble electronics or sort components, whereas in biotechnology, it handles lab equipment precisely. Most importantly, its design supports integration with robotic arms as well as full humanoids, addressing the need for versatile end effectors in general-purpose systems. For now, Apex Hand is helping to overcome data scarcity in embodied AI, as better manipulation will foster richer environmental learning. And in the latest in vibe coding, Replit has released its Agent 3 AI to supercharge software creation. Designed as an autonomous teammate, it requires no coding skills and operates independently for hours. With a 10 times boost in autonomy, Agent 3 handles tasks from coding to testing, improving apps in real time. Its validation system ensures flawless software, checking buttons, APIs, and data sources efficiently. Agent 3 can even build other agents, automating complex workflows via natural language, empowering users to innovate freely. Meanwhile, NVIDIA has introduced Physics Nemo, an open-source AI platform designed to revolutionize modeling and simulation in science and engineering. Importantly, this tool addresses a critical challenge in AI-driven physics, integrating domain knowledge with data to create surrogate models that enable near real-time simulation workflows. Unlike traditional models limited by data-only training, Physics Nemo offers a scalable, user-friendly pipeline that fuses data with expert knowledge, enhancing generalizability and usability. Traditional frameworks often fail to combine data-driven approaches with domain-specific insights, resulting in models that struggle to adapt beyond their training sets. Physics Nemo overcomes this by providing a flexible architecture that allows researchers to embed physics-based principles into AI models. This ensures simulations remain accurate across diverse scenarios, from fluid dynamics to structural analysis. The platform's open-source repository fosters collaboration, enabling researchers to share models, reference applications, and workflows with computational scientists and engineers worldwide. Physics Nemo simplifies the development of AI-augmented workflows, making advanced simulation accessible to industries tackling complex multi-physics problems. Furthermore, its optimized pipeline supports rapid training of AI surrogate models, reducing computational bottlenecks. For example, a renewable energy firm has already used Physics Nemo to train a super-resolution model for wind farm design. The model emulates large eddy flow in turbine wakes 4,000 times faster than traditional simulations, optimizing layouts for efficiency and cost. And finally, Figures 02 robot was seen being demoed in the real world, but tell us in the comments whether you think it's ready for prime time. Anyways, make sure to like and subscribe for more AI news, and check out this video here to learn more about the latest NVIDIA developments.